So now that we've done all that work where we squared binomials, basic binomials, and even binomials with radicals, we should now be ready to move on to the heart of the lesson, really the main lesson itself, which is solving radical equations. The only difference is that these radical equations that we're going to look at are going to have multiple square roots in them. Okay, so you guys have been used to seeing radical equations where it was like the square root of x plus 2 equals 7, where there was only, as you guys can see, where there was only one radical in the problem. So we're going to look at today is we're going to look at problems where there is more than one square root that we have to deal with. Okay, so the idea is if you have multiple radicals that you're going to have to isolate individually and then square again. So the more radicals you have, the more squaring you're going to have to do. Okay? So here's my first example. As we read this across, as you can see, it looks pretty complicated. I have a 13 minus the square root of x plus 11 equal to the square root of x plus 50. So this is what I mean when I say this is a radical equation where there is more than one radical in the problem. Obviously on the left-hand side here you can see this radical, a negative root x plus 11, and on the right side you can see the other one, the square root of x plus 50. So we have two radicals. So because we have two radicals, we're going to have to work on getting one radical isolated, squaring it, and then because there's two, one here and one there, we're going to have to square twice. So these problems are kind of labor intensive. Okay? There's going to be a lot of work. You just have to be very careful with how it is that you're doing it. Okay? But the first thing we're going to do is we're going to try to get rid of at least one of the radicals that we can. Okay? So if you look on the left-hand side and on the right-hand side, these radicals are already separated. So I can very easily, on the right-hand side, get rid of this square root. Okay? Well, as we've done in the past, since we have a square root, the way we can get rid of this is to just square it. So what I'm going to do is I'm going to take this entire right-hand side, and I'm going to square it. Now, what that does for me is that knocks out the radical on the right-hand side. So squaring the square root knocks it out. So that gives me, on the right-hand side, a very nice looking x plus 50. Now that gets rid of the radical on the right. This part's gone. It became the x plus 50. But if I squared the right-hand side, as I did, if I square this right-hand side, that means that I'm going to have to square this entire left-hand side. I cannot individually square the 13 nor square the radical. This is one big binomial over here. It's got two terms. The subtraction sign separates the 13 and the radical from one another. So this is a two-term, or in other words, a binomial. So I am going to have to square this entire side. So what this looks like then is this kind of looks like what we just did. The only difference is now we just have a more complicated square root. We worked with just basic square roots where it was just a variable underneath. Now we just have something else underneath. Okay? So I'm just going to write this multiplication out. Again, that's squared. This squared tells me that I have two of these now multiplying. So I'm just going to write this out twice. So I have, on the left-hand side, I have a 13 minus the square root of x plus 11 multiplying with another 13 minus the square root of x plus 11. Okay? So that's what's working with on the left-hand side. Let me just kind of clean this up a little bit. to show you that it's now being squared. Now, the right-hand side's done. It's already an x plus 50. We took care of that right away. It's now this side right here that we're going to have to multiply out or FOIL out just like what we did before. So this is where you must be careful. Okay, you have to just take your time and just go through each one of the 4 multiplications. There's your first multiplication, the 13 times the 13. That's the 169. Now I'm going to take that 13 and multiply it with this end radical. And just like you saw, the 13 has to stay outside. So it's a positive 13 multiplying with a negative radical. But the 13 is going to stay outside of that. So this is going to then give me a negative 13 root x plus 11 for that second multiplication. Here now is my third multiplication, which is going to be the same, negative 13 root x plus 11. And now my last multiplication, again, it's a negative times a negative. So these two radicals, the negative times the negative, that's going to be my positive. And now my two radicals multiply, and because they're the same, the square root is going to cancel. So, let me show you that again. A root times a root cancels. So that x plus 11 and the x plus 11, both under the square root, when they multiply, it just becomes an x plus 11. So it's right here on the end where that radical goes away. Okay? So what I'm going to do now is I'm just going to condense things as much as I can. I have the 169 at the beginning. I can certainly condense the negative 13 root x plus 11 and the other negative 13 root x plus 11. So there's my negative 26 root x plus 11. And I still have that positive x plus 11. And then obviously over here, nothing's changed. That stays as my x plus 50. So what I'm going to do is I can further condense, because as you notice, I have an 11 and I have a 169. Those are numbers free and by themselves, so I can combine them. The x I'm just going to bump to the front. So it's going to look kind of like where we put the highest power first. I'm going to have that x minus 26 root x plus 11, and then the 169 and the positive 11 combined to give me a positive 180. And now I'm equal to my x plus 50. Okay, so that's what the work should look like so far. Go back, look through, make sure that you can follow all the multiplication, because the most difficult part of this comes from squaring right up here. That's, if you're going to make a mistake, this is where you have to be really careful with your work. And foiling that out, multiplying out, however you want to look at it. Okay? What I'm going to do on the next page is I'm going to hopefully remember what I just wrote. And then I'm going to continue and pick up this work. Okay? So if you need to rewind and see that work again, or see that explanation again, by all means, please do. But you have to be able to get to this point down here. This is the most important thing, because now this is going to set up how we solve the rest of this equation. So here I'm at. After squaring that left-hand side, I wound up with this, all this nastiness over here on the left, and the easy x plus 50. Now what you may have noticed is that I got rid of one radical. When I squared that right-hand side, I got rid of the root x plus 50. But what that created after squaring that binomial out is it created another radical. So what this problem is now is this is just like what you guys did earlier. What I have to do now is I have to try to, if I can, to isolate this radical. In other words, I need to get this radical by itself. okay, because it is an equation that has one radical. In equations that have one radical, you always want to get that one radical completely by itself. So that's the first thing I'm going to work to do, is I'm going to work to isolate this radical. I want this radical by itself. Okay? So if I want this radical alone or isolated or totally by itself, I have to do a couple things. The first thing I'm going to do is I'm going to first subtract over the 180. That's going to move the 180 over to the other side, so I'm going to subtract it from over here. And I'm also, at the same time, going to get rid of this x on the left-hand side. So since it's a positive x, I'm going to subtract that x over. So this will subtract off and cancel. That will subtract off and cancel. And there's the minus x that I have to do to the right-hand side. So what I'm left with now on this left-hand side is I'm left with just this radical, which is attached to the negative 26. So I'm just going to drop that down. So it's negative 26 root x plus 11. Now over here I'm equal to, these x's, as we already saw, canceled out. And now I have a positive 50 and a negative 180. Well, 50 and negative 180 make negative 130. So this is what I've got. I've got one more thing to do before this square root is totally by itself. And this step right here is to divide. This negative 26 is a multiplier. So in order to get rid of this multiplication, I have to divide everything by negative 26. So I'm going to do that to both sides. Now, I have the square root of x plus 11, because these divided out. And now when I take negative 130 divided by negative 26, I get a positive 5. Okay? This division over here should always turn out nicely for you. Okay? This should always be a nice answer for you. Shouldn't be anything weird like a decimal or a fraction or anything strange like that. It should be a nice looking thing. And now what we've created right here is now we have a single radical equation. Where now, to solve this, it's pretty straightforward. Now that it's by itself, now we just square both sides. Squaring kills the square root. We've got x plus 11 equals the 25. When I subtract the 11, I get that my answer, that my x value is equal to 14. And that's the answer that solves this radical equation. Okay? So we just had to square both sides and then isolate the one remaining radical. The one remaining radical that we had was right here. And we just got rid of the x, we got rid of the 180, and then the last thing we did before squaring is we had to divide by that negative 26. Okay, so move the x's, move the number, and then do the division, then worry about squaring. Okay, that kills the remaining square root, which then solves it up very, very nicely. Okay. And the next video I have for you is my second example. I'll go through it just like I did this last one with you.